So what we have is basically two processes for air scrubbing. One is chemical and one is biological. The first step for both are the same. So the ammonia, which is a gas, it dissolves into water, into ammonium, which is a positively charged ion or molecule. And in this process, alkali is produced, and that means the pH goes up. So it goes higher than 7. And the higher the pH rises, the less ammonium will dissolve in the water. So the rate will go down and down when more ammonium dissolves. That also means that in a lot of countries we see systems where just water is used without any acid or without any bacteria. That just means it doesn't do anything, because a little bit of ammonia is dissolved at first in step 1, but the pH goes up, and after a little while nothing will happen anymore. So whatever happens when it's just water that's being used, you will know that nothing will happen after a very short amount of time. So what we do in the chemical process is we add sulfuric acid to the water. It will lower the pH, usually 3 or 4 in normal systems for pig or poultry houses. This has actually two things will happen. The pH goes down, so more ammonia will dissolve in the water. And also the ammonia is bound by the sulfate. So this results in ammonium sulfate, as you can see below, which is a stable salt, so it will remain in the solution, and it can also be used as a fertilizer. The second process is biological. So the first step is always the same. The ammonia dissolves into the water, which makes the pH goes up and the dissolving rate goes down. So in step 1, we have the bacteria species, usually Nitrosomonas and Nitrosococcus. They convert the ammonium to nitrite by using oxygen, and in this process acid is produced. That means automatically the pH goes down and the ammonia dissolving rate goes up with that. And then there is a second step, species usually Nitrobacter and Nitrospira, and they convert the nitrite to the nitrate. And in that process, in total, ammonium nitrate is formed. And this is also a stable salt, so it will remain in solution. And it's also used as a fertilizer. So these bacteria, they are not special. They are naturally occurring. They grow in soil and in open waters, and use the same processes. It's called nitrification over there to convert fertilizers and that kind of stuff to make sure the plants can grow from it. So what is very important in this biological part is that it's a natural occurring process, but it should remain stable for the ammonium nitrate to form. So what is important is that the pH will be neutral around 6.5 to 7, and that the temperature rates, as you can see on the right side, is at the right level. As you can see, from about plus 13 degrees Celsius to plus 43 degrees Celsius, the process is about over 70%. But beyond that, so when it's colder or warmer, it goes down very rapidly. So this process is stable when about 50% of the ammonia is converted into nitrate. Because then the same amount of alkali and acid is produced, which keep the pH neutral around 7. And as you can see at step 4, the ammonium and the nitrate also consist of equal parts of ammonium and equal parts of nitrate, which means that the conversion rate of 50% makes an ideal solution. A small note to the side is that step 3 is not always taking place or not fully taking place, which means that only nitrite is formed. And this is not a problem because ammonium nitrite is also a stable salt and also a fertilizer. So what are the comparisons? The chemical processes, the applications usually are poultry, pigs, cattle and manure treatments. So to say all the processes in our business. It is a stable controlled process, also for high ammonia content for the manure treatment. Sulfuric acid is used. We have highest ammonia reduction speeds, 70 to even up to 100%. but lower odor reductions. Around 30% is maximum for chemical air scrubbing. And what we have is less wastewater, but with a higher nitrogen content. But it is acidic, so take care. Biological processes, the applications are mainly pig and cattle. It's a natural process. There's a chance of instability. As you can see at the first slide, the temperature is important, but also the ammonia should be below 45 ppm and continuous. That means manure treatment often has higher levels, which will kill off the bacteria. And the thing is with poultry, there's often periods with almost no ammonia and periods with higher ammonia, which makes the process unstable. The other thing is with biological air scrubbers, usually a slime, a protective layer for the bacteria will be formed on the package, and the dust from poultry houses will get into this slime and will clog the package very rapidly. What we use is pH stabilization, sulfuric acid and caustic soda to push the bacteria a little bit to remain stable. We have lower ammonia reductions, 70 up to 85%, but on the other hand, higher odor reductions, 45 to 75%. And what we have is more wastewater with a lower nitrogen content. So wastewater from biological systems is about 8 to 10 times as much as from chemical systems. For poultry, the biological is not really viable, as I said, but there is a preference for biological systems, mostly because of the odor reduction and also because it sounds friendlier, of course. Wastewater. Both processes produce wastewater. So what is the wastewater? It's a liquid fertilizer. Both the biological and the chemical wastewater are tested and accepted as fertilizer in the European Union. There are also official papers from several universities on it that also have been sent to you. It can be used on the land or upgraded at a processing company. It should not be stored with the manure or the slurry because toxic gases can form. And of course, local regulations always apply. For the chemical wastewater, as we said, ammonia sulfate, a nitrogen content between 28 and 58 kilograms per cubic meter. It is acidic, so the storage facilities should be suitable, and it should not be used on bare soil, at least not on plants, because it can burn on the leaves. So it should be neutralized before the use on land, or as discussed before, on rice fields as well. The biological wastewater contains ammonium nitrate. It is a very low nitrogen content, about 2.8 kilograms per cubic meter, but it can also be used directly on the land. So it's much easier to use, but there is a bigger volume.